Here we are going to perform the activity 1. So for that, here we have a watch glass and a magnesium ribbon. A magnesium ribbon is there, and a watch glass is there to collect the remaining after burning of magnesium. So here what we are going to do is just take the magnesium ribbon and keep it in just nearby, I mean closer to the flame. So that time you can see that burning. So it burns with a dazzling flame. Okay, it burns with a dazzling flame, and after some times what you can see is you collect the white ash, which is called magnesium oxide, that have to collect in a watch glass. So magnesium burns to form magnesium oxide, that is the white ash which is being collected. Okay. In a combination reaction, we have learned that calcium oxide, this is called quicklime. When this calcium oxide is added to water, so you will get a slaked lime. A slaked lime is nothing but calcium hydroxide. Okay, look at here. This is the quicklime. Okay, this is the quicklime. This quicklime is also known as calcium oxide. Okay, so let's see what happens. This quicklime is added to water. Okay, this quicklime is not that much soluble in water. It will slowly it dissolves in water. For that, let's take a glass rod to dissolve this quicklime into water. Okay, you can use this glass rod. By keep on stirring, you can see that slowly it will be dissolved in water. Okay, here look at here, we are going to add this quicklime into water. Okay, a portion of quicklime we have added to water. So by the time we add, you can see that it never dissolves. It never dissolves, so that you can use a glass rod. So by keep on stirring, it will be slowly dissolving. Okay, I hope you can see the dissolution in water. Okay, this quicklime, it will take time to dissolve, but it never dissolved completely. So look at here, it never dissolves completely. It's slowly settle down at the bottom. This is the calcium hydroxide solution. Okay, this is the calcium hydroxide solution. Look at here. Look at here, this is calcium hydroxide, that is called slaked lime. Okay, when we touch this beaker, you can see heat energy is coming out. So this is combination as well as an exothermic reaction. Okay. Students, we are performing activity 1.3. See the procedure in your textbook. Okay, so activity 1.3 is mainly we are doing by taking the 3 apparatus, and this is a beaker. Beaker have dilute sulfuric acid. Dilute sulfuric acid means sulfuric acid is dissolved in water. Okay, this is zinc metal. So the zinc metal, we have crushed it into zinc granules. So after that, we just add the zinc metal into the dilute sulfuric acid. When we add the zinc metal into dilute sulfuric acid, you can see some gases coming out. Okay, this is this is the cork. So we just close it with a cork, and a glass tube is kept it over there. So by the time you can see inside the conical flask, you can see it gets condensed. This is due to the formation of a hydrogen gas. Look at here, this is get condensed. The inside wall is get condensed because the zinc metal reacts with the dilute sulfuric acid and produce hydrogen gas. Okay, so that you can see that a condensation inside the conical flask. Okay, which has also condensed on inner wall of container because of the formation of hydrogen gas. Okay. Okay, students, in this activity, we are doing the thermal decomposition of lead nitrate. Here we have taken the lead nitrate salt. Here a test tube is there to collect the lead nitrate salt. This is spatula. The spatula is used to collect the salt. Okay, take the salt in a test tube. The test tube should be dry. Okay, after that use a test tube holder. Okay, use a test tube holder and you just heat it. Here what is happening? Yes, we are doing thermal decomposition of lead nitrate. Using heat energy, this salt is going to break down into simpler products. Just observe the bottom of the test tube. Can you see anything? Just observe carefully. You can see a gas is coming out. Okay, look at here. A gas is produced. What is that? Yes, a reddish brown gas is produced. That is nothing but nitrogen dioxide. You have learned that lead nitrate undergo thermal decomposition and produce lead oxide and nitrogen dioxide and oxygen gas. This reddish brown gas is the nitrogen dioxide gas. You can see the reddish brown gas is produced when you heat a white color lead nitrate. Okay, this is the nitrogen dioxide gas and you will get lead oxide and oxygen also in a during this reaction. So a singular reactant is decomposes to form three different products. The reddish brown gas is nitrogen dioxide. Along with you can see lead oxide and oxygen gas. Okay. Okay, this is activity 1.5. The next example for thermal decomposition. Here we have a dry test tube, no water at all, and ferrous sulfate crystals we are taken. Okay, this is ferrous sulfate crystal having pale green color. Okay, that pale green color ferrous sulfate salt we have taken in a dry test tube. Okay, this is the ferrous sulfate salt and just hold it with the test tube holder. Look at the color, you can see it is pale green. Okay, so what happens when you heat this ferrous sulfate? You can see three observations. So ferrous sulfate is green because of the water molecule. So when you heat it up, you can see the first observation that water molecule is loses out. You can see the water molecules which are present in ferrous sulfate is just escaped from the test tube. You can see the water vapors. First the water vapors are loses out when you heat ferrous sulfates. That time the color changes to reddish brown. This is the second observation. This reddish brown color is due to the ferric oxide formation. That ferrous sulfate is turns to ferric oxide because it undergoes thermal decomposition and you can see a smell of burning sulfur. The three observation is noted. Okay.
When an iron object is kept in copper sulfate solution, the color of the object and the copper sulfate solution changes. Let us perform an activity to find out the details of this color change. For this activity, you will require iron nails, sandpaper, test tubes, copper sulfate solution, thread, clamp stand, and test tube stand. Take two test tubes marked as A and B, and in each test tube pour about 10 milliliter of copper sulfate solution. Fix test tube A on the clamp stand and keep the test tube B as control sample in test tube stand. Now, take 3 iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube A for about 20 minutes and keep the third nail aside. After 20 minutes, take out the nails and keep them beside the unused clean nail. Do you observe any change? On comparing both the nails with the unused nail, you will find that the iron nails which are kept in the copper sulfate solution have developed a reddish brown layer on them. Now, take out the test tube A from the clamp stand and keep it beside test tube B for comparison. On comparing both the solutions, you will find that the original deep blue color of the copper sulfate solution has faded away. What is the reason behind these changes? When iron nails are dipped in copper sulfate solution, the iron metal reacts with copper sulfate, which results in the formation of ferrous sulfate and copper metal. In this reaction, iron being more reactive than copper displaces copper from the copper sulfate solution and forms ferrous sulfate, which fades the deep blue color of the solution. The displaced copper then deposits on the iron nails in the form of a reddish brown coating. Since in this reaction a more reactive metal iron displaces a less reactive metal copper from its compound, it's a displacement reaction. In this module, you have learnt that iron metal displaces copper from its compound copper sulfate and forms iron sulfate along with copper metal. This reaction is a displacement reaction.
We are going to perform the activity 1.2. The 1.2 activity which is there in your textbook, that lead nitrate solution we have taken, it is colorless solution, and potassium iodide also we have taken, it is also a colorless solution. Okay, what we have to do is take this two solution and mix. So let's see what happens when you mix this colorless solution. Okay, to the potassium iodide if you add lead nitrate, you can see that yes, look at there, a precipitate, an yellow colored insoluble substance is formed. This is the precipitate. Okay, that yellow colored precipitate is nothing but lead iodide. That lead is insoluble. Okay, so okay, this lead colored insoluble substance is the precipitate, because lead nitrate reacts with potassium iodide and form lead iodide. Okay, this lead iodide is the precipitate which is formed, which will not be soluble in water. Okay, this is the best example for double displacement. This is also. Now let's see the next example for double displacement reaction. For that, here we have taken a barium chloride solution and a sodium sulfate. This is sodium sulfate solution and we are adding barium chloride. Look at here. When you add barium chloride to sodium sulfate, you will get a white colored precipitate. A white insoluble substance is formed. Okay, this is the double displacement reaction and this is the precipitation reaction also, because both reacts to form barium sulfate precipitate showing white color. Okay.